All right, good morning. Today we're going to be talking about circular motion. And the way in which we are going to study it is I have a little device here, which I will feed through a string, and I'll have a weight on the bottom of it, and I'll be swinging a cork around. So the device looks something like this. Kind of a simple looking device. So I have like a little tube here. The tube is made so that there's out of material that there's less friction here with the string. So we're going to have a string. On the end of the string will be a cork. And we have to be careful here. The cork's mass is indicated by lowercase letter m. And down here we're going to hang a weight, which will be capital letter M. We will be swinging this around a circle of radius capital R. Okay, so now to review a little bit of the theory for this. If you recall back for circular motion, the sum of the forces toward the center of motion for an object must be equal to the mass of that object, in this case our cork, multiplied by the centripetal acceleration. And so if you remember what the centripetal acceleration is, type it in chat what the centripetal acceleration is. You remember? You all forgot. All right, so shall I say? Do I have to type it? All right, so it's v squared over r the radius. It's v squared over r the radius. Okay. The force toward the center of this thing is caused by this mass. Now, what we're going to do is we're going to have this mass holding steady here. So in other words, I don't want this mass to be moving up and down while I'm swinging this thing. So if this mass isn't moving, then the force of the tension in the string is going to be equal to the weight of the mass. So if I have a mass of capital M, how do I calculate the weight? How do I calculate the weight? If I have a mass of capital M, how do I calculate the weight? Type in chat. How do I calculate the weight of anything? Mass capital M, how do I calculate the weight? Gee. I wonder if anybody's going to get this. Not divided by, but yeah, you take the kilograms, you multiply by 9.8. So this is going to be mg. Okay. The problem is that experimentally, we can't measure the speed directly. We can't measure the speed of this thing directly. So we're going to have to calculate it. And so what we're going to do is we're going to find the period of the motion. The period. Okay. So we're going to find the period of the motion. Okay. And we're going to need to relate that to that. So we're going to find the period. And so I'm going to come over here. The period, remember, is the time for one cycle. So in other words, it's the time for one complete revolution of this thing. So the time for one complete revolution is the period. Okay? And we're going to use capital letter T for that. So this is capital letter T for period. Okay, so now the speed, V, And I want to emphasize we're talking about speed here, even though we use the same letter as velocity. When I talk about the speed, what is the speed of anything? Speed. Distance over time. So in one circle, what is the distance that the thing will travel? If one circle. So for one circle, what's the distance? What do we call the distance? One circle. Circumference. Good. Jose, good job. So what is the circumference of the circle? What is the circumference of the circle? It's 2 pi times the radius. So this is going to be 2 pi times the radius divided by the time it takes to get around. And the time it takes for us to get around once is called, we define it as the what? Period, capital T. So this is 2 pi times the radius divided by our capital T. Okay, so I can plug that into there, and I have to square it. So I'm going to do this. I'm going to say, then we're going to do a little bit of simplification. So I've got mg equals little m divided by capital R multiplied by 2 pi r divided by t squared. So now let's do a little bit of algebra. M times g is equal to m 2 square. I have to square every term in this thing for pi squared capital R squared divided by, there's an R here and a T squared down here. Some things, there's a little bit of cancellation here, and we're going to solve this for G. Okay? So we're going to cancel out one of these R values. Okay, one of those R values. And then I'm going to divide this by capital letter M. And what I do is I get an equation that looks like this. So I get that G is equal to 4 pi squared lowercase letter m divided by capital letter M multiplied by R over T squared. Now, the idea of this lab is to examine the change in the period when the radius changes. The change in the period t when the radius changes. So the thing is that once we set this up, once we set up everything, okay, little m, capital M, then this number will not change for all of our radiuses and all of our periods. And so we scientists like to make shortcuts because I don't want to go putting 4 pi squared little m over capital M in my calculator every single time. Every time I go around. So what we do is we say, okay, since I don't want to do this so many times, what we're going to do is we're going to say, okay, so we're going to have G equals, and then we're just going to say, okay, well, this is just a constant, K, kappa. So we're going to call this kappa because, you know, I don't know, use C for other stuff. So I called it kappa, Greek letter kappa, and that's R divided by T squared. And so what we're going to do is you're going to calculate the kappa for our mass, our two masses that we're going to use. So you're going to do that first, and I guess put it somewhere down here. We'll calculate the kappa. All right. So I'm going to pause the video portion And then I'm going to set this thing up in front of you. Okay, so I'm going to pause the video. Okay, so I'm back. I made the device here. I have the cork attached to the spinner device and attached to the weight at the bottom. So for our data here, I'm just going to give you the two masses that I have put on there. The mass capital M, the brass weight is 45.0 grams. So these weights are in grams. And the lowercase letter m is equal to 12.5 grams. Now, there's something I want you to notice. When you're calculating this value of kappa here, so kappa that you're going to calculate and put on the side here, 4 pi squared little m over capital letter M. Okay, I have a question for you. What are the units of the kappa there? What are the units of that? What would that be? Any brave person want to answer that? No, you're off. No unit. That is correct. Because these two units of mass are going to cancel each other out. So when you're actually calculating, you do not have to convert these. You do not have to convert these to meters. You can simply leave them in centimeters. Okay? So you just leave them in centimeters, and then it'll be fine. I'm sorry. You don't have to convert them to kilograms. You leave them in grams. Then it will be, everything will be fine. Okay? So somebody calculate our kappa for us. Just type out what you get in the chat. Give me like 3 decimal places or something like that. So the whole number in 3 decimal places. I think that should work. $10.97. Okay. 10.97. No, 10.966. That sounds good. Okay, so our kappa is 10.9. 10.97, and it's just a number. Okay, 10.97. All right, now let's see what I can do. I'm going to pause the video for a moment, just so I can, because I have to set up one more thing with this thing. So I need at least 2 volunteers to be vocal in the chat while we do this. The reason why is because I was trying to count when this thing was spinning around, and I found that it was almost impossible to do that while I was trying to maintain a spin and worry about that. So what I need somebody to do, so the instructions say, let's see, what did they say? Is that you're supposed to time for 15 of swings once I get this stable. So in other words, I'm going to start swinging it around until I get it stable. And then once I get it stable, I'm going to say that it's stable. And then I want somebody else to say start and do the counting. All right, so you're going to count 15 revolutions around, and then you say stop, or you just count the number of revolutions. So any volunteers, or do I start calling on people? There's 24 of you. No, wake up, oh. All right, here we go. All right, number 3. Alyssa, are you there? Oh, I'll do it. Okay, Roman. Okay, I'll explain to you. So go on voice and I'll explain to you what you're supposed to do. Roman's going to do it. Alyssa, your luck. All right, so here we go. So I'm going to kind of try to explain what you're supposed to do, Roman. So everybody get their timers, and the timers need to have hundredths of a second. So what I'm going to do is I'm going to try to get this stable. Once I get it stable, I'm going to say it's stable. And so then what Roman is going to do, he's going to say start and start counting. You want to count 15 of these going around. 1, 2, 3, 4. I can't count and keep it stable at the same time. So my job is to keep this thing stable while you count to 15. Everybody else you guys need to be timing. You guys need to be timing this until Roman says stop. When he says stop, I'm going to grab this like this. So you are counting 15 of them. Yes. Okay. All right, you ready? All right, let me get it stable here. All right, it's stable. Go ahead and start when you do it.
Okay. Start. Stop.
Okay. Thank you, Roman. Now my other job here, which what makes this really difficult, is I have to lay this down on this ruler and tell you about how the R radius here. So the radius of this one is 10.5 centimeters. So 10.5 centimeters is your R. Okay. The times, use your own time in chat. Whatever time you got, that's the one you're using. And so the R for the first one is 10.5 centimeters. Okay, I'm going to go ahead and put my R's in centimeters here. And the T15 is whatever the T15s are up there. I'll pick one at random here. You use the one for your group, okay? So it looks like I got a 6.23. So it's random.
Professor.
And this is in seconds. This is in seconds, okay?
Professor, why does it say time for 10 revolutions? Isn't it 15?
Oh, it should be 15. That's a typo. That's a typo. It should be a time for 15. Time for 15. We like 15 because it doesn't divide into things, so you get more digits and you can round off. Okay, so it should be time for 15. Yeah, makes it a little bit more accurate. All right, so now what I'm going to do is I'm going to extend this a little bit farther. The problem is with this is I can't choose my radius before I actually do this. I can kind of estimate it, but I have to get it stable, and during that time when I'm trying to get it stable, the radius might change. The way that I generally do it is I try to swing it until I feel a tug. See, notice I have my fingers here. If I swing too fast, I start feeling a tug. So I back it off until I no longer feel the tug. Then I let go because I don't want my hand there. Oh no, it's not stable. Sorry. Let me try it again. I tried to get too fancy. I waited too long. Sorry. So the problem is this bottom will start swinging and stuff if I mess. Not right there. For stable, start when you want.
Start. Stop.
Thank you. This one was 23 centimeters. And we got about 8. Okay, good. What was this? So I just picked one. So don't use my data. Use the one you and your partner come up with, because it's just as good as me. Because I'm picking one of you at random. Okay, it's about this far. Okay, stable when you want.
Start. Stop.
That one was 43 centimeters. Okay, let me do it once a little shorter. Sorry, I'm trying to do this one. Let me try to. Ah, no, stop. Yeah, there was a, if we were doing this live, there'd be a real division of labor in terms of who's doing what. One person would be doing the spinning, one person would be doing the timing, one person would be doing the counting, and the other person would be doing the holding up of the ruler to measure the distance. All right, let's try this one. I hope it's a different one. I hope it's a different distance than the ones I have. If not, I'll redo it. So go ahead and it's stable. Go ahead and start when you're ready.
Okay, start. Stop.
Oh no, I lost it. I lost it. Sorry. We have to do that one again. My bad. That happens too. Oh, I'm sorry. Sorry, everybody. Sorry, everybody. All right, ready? Yeah. Just swinging. Stop swinging. All right, we're stable again.
Okay, start. Stop.
That one was 32. Okay. I hope that was right. 9.80 here. Something like this, and then 32 was a 32 one. I don't know if I necessarily wait. Oh, whatever. You're going to use your times. I'm just copying those up there. All right, let's go for a big one. Here we go. Oh boy. Can you feel it? Oh, damn, stop that. Come on. Get it as stable as I can. All right, that's as stable as it's getting. Start when you're ready.
Start. Stop.
I have a bad feeling that this one's not going to be good at all. That was 75 centimeters. I think that one was too much, but we'll see. Just pick one. 3, 2. All right, that's all of our data. So let's do the analysis. Be nice and quick. All right, so we'll go here and go to there's a 10.5, 23.0, 43.0, 32.0, and 75.0. Those are the numbers I wrote up there. And then the times, don't worry about the times I put up there. You use your time that you or your partner got. Okay, so hang on, I need to. So I'm going to pull up Excel here, I guess. Oh, that wasn't Excel. Give me Excel. I believe that was 43. Yeah, 43. Sorry, my writing is okay. All right, you're all ready. I'm gonna share my screen. Oh, let's see.
So are we also supposed to do the Excel on our end?
No, you don't need to do Excel at all for this. Well, yeah, you actually do, but you could use a website if you want to. There's only one thing you have to use, or that you would, the semi-required, to do Excel for, and that is the average and standard deviation of the values that we get. But up to that point, you don't have to do anything, and you can use a different website. So you do have to calculate an average and standard deviation. The only reason why I like using Excel online is because it's easy for me to type into and show you how I'm doing things. That's the only reason why I use it, because I can just share the screen like this, and now you guys can see the Excel. You can see my Excel, there it is. Hooray. Okay, sorry. Bring up the chat. You guys feel free to ask questions, please. Because I like questions. Indeed you do. All right, so the first thing I need to do is I need to take the stuff in the table that's below, and I need to transfer that to the table that's in the upper right. Okay, so the table that's below and the lower left, I need to transfer it to the upper right. So instead, we're going to have a capital R, and we're going to have the period T. So these are the two things that we're going to do. Now, in this case, we can have units of meters or centimeters for the radius. It doesn't matter. It's just whenever you get an answer at the end of this whole thing, whatever that unit is, that's the unit that the calculated G values are going to be in. So for this R, what would you guys like to use, centimeters or meters? Either one. It's fine with me. Type in chat or tell me. First person gets it. All right, centimeters. Okay. So all you have to do is take the numbers from down there and transfer them up there. And don't forget to put the little CM in your table. And so we're just going to transfer numbers. So I'm just going to transfer numbers. Okay. And I'm going to transfer these in order of increasing, just so I can see patterns. So 10.5, 23.0. The next one was 32.0, and I'll fix that. 37.0. Wait, yeah, that was 32, 43, and 75. And by the way, I do want you guys to realize something that I'm not saying here. Let me see. And I need to, oh man, I can't do a subscript? Oh, that's fine. Why can't I do a subscript? I swear. Oh, slow down? Okay. Oh, I just typed those things in. I'm not really. I just want to make a note of this somewhere, because in other words, those, if I just wrote down the numbers, notice if I just wrote down these numbers here, that would imply that that's measured to within 0.1, but it wasn't really. It's measured to within 0.5. So the significant figures actually would lie a little bit in this case. So that's why I kind of want to make sure that I have the little sigma equals that. That wasn't 37, that was a 32. Yeah, let me switch back to the big B. I'm sorry. That was a 32. That looks like a 37 on the board. Oh, I estimated the sigma. So that's when you estimate the sigma, you want to be reasonable about how uncertain you might be. Oh no, there was just a 32. It looked like a 37, but it was a 32. Because somebody was asking about 37. So your time, what was your time for the 37 that you're thinking? Because I think that 32 was like a 7.5 something or another. No, there's only 5. Here, let me show you. Okay. All right, so now what I want you to do is I want you to take your times and divide them by 15 and transfer them to the table. So you're going to divide each of your times by 15 and transfer them to this table. So somebody tell me what you got, your time divided by 15 is for the 10.5. And you're going to keep 3, you're going to keep whatever you, 0.41. Can I get one more decimal? Okay, there we go. Okay. What about the one for the, what about somebody else? Take the 23. Okay. Somebody else, different, take the 32. Okay, 0.523. Okay. I don't think that one's right, but what are you gonna do? Well, maybe, I don't know. It seems a little off. How about the 43? What are we getting for the 43? And then finally, what about that 75? Okay. All right, so the next thing you're asked to do is just to then calculate those values here, okay? So really, for each one of these, you're going to say that this is equal to our kappa number here, which is, oh no, I erased our kappa. What was our kappa? 10 point something or other? Oh no, I erased it. Okay, 10.9, I'll go ahead and say 10.97 times this divided by, I'll put parentheses, this times this, okay? Okay, so here's our first one. So I got, oh yuck, oh well. We didn't say it was that accurate. Let's see if this one's better. Now, that was a little better for me. Maybe some of you have timed it better. I don't know. That one seems a little bit better. All right, let's see about this 32 here. Oh, okay, well. Okay, so you have the shot the other way. All right, next. Oh, we'll come back down. It's a little closer. Ooh, that's the best one yet. All right, there we go. Kind of all over the place. Okay, does everybody have their G values calculated? Okay, not yet. Isabel, go on, calculate the rest of your G values. And Rick, or each partner can actually calculate the G values and make comparisons with each other. Are you making sure you divide it by the time squared? Because you have to square the time when you divide it. Okay, is there anybody that needs to wait before we go on with this? Okay, I'm going to assume we're okay to go on here. By the way, these are our measurements of gravity, so I'm going to put this. I'm just going to go here and say G, oops, G. And the units of these G's, and these are experimental G's. And they are in centimeters per second squared. And I can't even do a, sometimes I don't like Excel for certain things, and that's one of them. The fact that I can't do superscripts and subscripts. It doesn't make any sense. Anyway, boy, that's not very good at all. G, I'll just put G. All right, so now what we want to do is we want to do an average and standard deviation. So you can use Excel, or you can use another program. You can use that easycalculation.com. That'll be fine. I'm going to go ahead and use Excel since I've got it here. So I'll just say equals. average, and then highlight it. Do this. 980.606. Okay. And down here, I'm going to equal std s. Highlight this. And press return. So this is what I got. Oh, ouch. All right, so now I'm going to ask a question, and we can't really do the questions in the textbook. Okay, there's one more calculation. So this is the G, and this is the standard deviation of G. Okay, so that's our experimental G and standard deviation phase. Let me do the percent uncertainty here, because that's what it has in number 4 for you to do it, except for I'm going to do it as a percent. Anybody remember how to do percent uncertainty? Anybody here awake? Awake, wake up. The guys need more coffee, come on. 2 weeks ago, you were all typing and chat and everything. Now you're like, ah. Come on, this is our last lap. Come on. Just think. If it hadn't been for coronavirus, you'd be taking a lab final right now, okay? So there you go, right? Yay, coronavirus. You get to do a silly thing with this, with the circular motion lab. That's it. Actually, no, I'm telling. Somebody has to put it in chat. Or at least say it. All right, let me go back over here. All right. Test. All right, you guys have to calculate this thing. So we're going to do a percent uncertainty and a percent error here, even though it doesn't ask you for a percent error. I think that would be cool, especially in this case, because the result actually turned out to be a little bit more decent than I thought it was going to be. So for percent uncertainty, okay? So percent uncertainty. You take sigma g and divide it by g, and then to get this to a percent, what do? What do you do to make it a percent?
Multiply by 100.
Yay! Somebody's awake, sort of, right? You're waking up. So you just multiply this by 100. Okay, so put the answer to number 4 in terms of a percent. So you're going to do a percent uncertainty here for number 4 on your data table. And I'm going to add a number 5 on the data table. I would like to have the percent error. The percent error is the experimental G, whatever you got, minus the accepted value of G, divided by accepted value of G, and you multiply it by 100%. The accepted value of G is 979.7 centimeters per second squared. This is specifically for Northridge. Woohoo! This is our Northridge value. So guys, tell me what you got for the percent uncertainty and the percent error of this thing. So I'm waiting for percent uncertainties and percent errors to pop up in the chat. Once like the last thing I have to do today. Okay, 23.3. That sounds reasonable. So Anna got some reasonable numbers. No. Sigma G is whatever Excel gives you for sigma G. So if I look at my sigma G, so we're actually calculating the standard deviation. We're not estimating it. My sigma G is 221.9. That's my sigma G. Okay, because so somebody else put some numbers in the chat, what you got for yours, percent uncertainty and percent error. They should be slightly different because your times are slightly different. Okay, sounds reasonable? All right. So now, turn it on the second page. You have those questions. On the second page, you have the questions. So since we are online and we don't have everybody in the classroom, so in other words, normally what would have happened is we would have different people with different setups. So they'd have different masses, different. Maybe I should have different. Oh. There you go. All right, that's better. Hey, you missed me? I'm back. All right. All right. So what happened is they'd have different masses, like we'd use this black cork instead, and in some of them we'd use two weights to weight the thing down with instead of just one. So what we do is we'd have a variety of different setups so we could see which setup worked the best. We don't have that today because you're all at home and I'm here and I'm only one person, so I'm only one person doing this. So you cannot do number one, but I mean you can do number one, but not the kind of number one question. Okay, hopefully you can do number one. My son learned how to do number one. Well, my son did number one when he was first born. Just, okay, I know this is bad. Okay, it's bad. It's a bad joke, okay? I always have to tell bad jokes. Okay, so skip the first question and skip the second question because the second question relies on the first question. So we skip those two questions. And so there are two other questions I want you to ask. One that will take the place of the first two, and then number three. So these are kind of thought questions. You answer these on your own. But what the one question I want to ask you guys, kind of that will take the place, or I guess I should say, I'm going to leave this. I'm going to erase this because I need to write the professor. So this is a thought question. Okay, so. Question. Okay. So these are the new questions. Better. That's number one. You're not doing two. You're not doing. Actually, I'll just say the new question. Answer the new question first. I want you to answer the new one first. Okay. I don't know how to do that, but answer the new one first. Okay. Describe the results of the experiment in terms of accuracy and precision. Okay? So you and your partner will get together, brainstorm, and answer that question. And then, of course, you're going to do the old number 3. Changes. What changes would you make? Suggest changes to make it better. Any kind of changes you and your partner come up with are fine.
So we only need to answer these 2 questions or something
Yes,
else?
yes, this is it. These 2 questions, that's it. That's it. Oh, so the first one I wrote on the board here. The first question, the new question I want you to do is to describe the results of the experiment in terms of accuracy and precision. So in other words, I want you to look at your numbers and describe the experiment in terms of the accuracy and precision of it. Oh, explain the first one? How do you say? You want to go all the way back to like the uncertainty thing. I think it still might be open. And things we discussed way back in like week 1, week 2, when we talked about accuracy and precision and the difference in them. We also ran into it with the ruler, the Acme rulers. We ran into it that week. So accuracy and precision. So you want to look up the differences of those definitions and kind of figure out which one of those or both describes this particular experiment. All right. Yeah, this will be our last like kind of lab that we have today. And I guess I'll hold a session 2 weeks from now for you guys, but it'll be for both of my labs. It'll be during finals week, so there's no required attendance on it. Oh, for the percent error, what did we use for the values? What values? The values for what? That's for the accepted value of G. Okay. For your value of G, the experimental value of G, you use your average value of G's. In other words, every one of those things that I calculated on that line here, let me show you. Oh, okay, you got it. Okay. Okay, so you use your values, you use your average G, and then for the sigma, you use the sigma G. There you go. All right, so I will be having a session a couple weeks from now. Just if people want to show me their notebook that way, you know, you can show up and show me your notebook. I'll put a thing to us for the journal. It's okay to just send the journal. Yes, yes. Go ahead and just send me what you had before class went on. If you have other stuff, great. Okay.
So after this, there is nothing else. Like this is the last class, and then there's
Yeah,
nothing else.
we replaced the lab final with this lab to
Okay.
give you something to do, because there's no way to really give you a lab final.
Okay.
Because you know it's a practical lab final, right? And you have to be wherever it is, and most of the stuff's in here. So yeah.
Okay.
So yeah, I just have to adjust the point values and everything. Scale
Good.
like mad, and
Is there another class, or this is the last one?
like I said, I'll be here in the last lab that we had in person was lab 6.
Yeah.
Lab 6 was the last lab we had in person. Lab 7 was in between. Because it's like you got the equipment before, you got the equipment, but then you weren't able to turn it in. So that's kind of the limbo one. And then 8 and beyond was all of those have been online. So lab 7 should technically be in your notebook. Yes. In the notebook. Yes. Only up to lab 7. If you've done more, great. Because I always grade everything based on relative scales. Scale everything.
So next, we are gonna have one more meeting, and then just during that meeting, we just show you the notebooks.
Yes. If you don't want to, okay, I'll have a place for you if you want to take pictures and put it online. You could do that instead. Okay.
And then you cannot participate in the
And
other.
then you don't have to participate in the 1-2 weeks. Yes.
Okay.
Okay.
Thank
So it's Emmerich, it's mostly for the take-home laboratories. No, there is no more take-home lab either. Your last take-home lab was the speed of light lab using a microwave. By the way, how did that work out for everybody? Did you get it? Did you get everything that YouTube said you'd get? Anybody not get what YouTube said you'd get? All right, Jose, Anna, and Rebecca, how many times did you do that experiment before it matched whatever was on YouTube? Yeah, see, 3 times. See, you're not supposed to do. It's okay. Don't worry about it. It's all right. For this semester, I won't even be worried about those, okay? So just submit them where I told you to submit it, and then that'll be fine. All right, you guys take care. I'll see some of you in 2 weeks.